So today in class we talked about unit fractions and multiplying fractions. We did paper folding, and from the paper folding we saw that basically we just multiply our numerators together, multiply our denominators together to get the product. We're going to move on and look at just a couple of examples. So the rule that we found for multiplying fractions is that if we had the fraction a over b times c over d, the product would be a times c over b times d. So what that looks like in the example we have here, 3 times 4/9, we would rewrite 3 as 3 over 1 times 4/9, and then we can just multiply straight across. So we have 3 times 4, which is 12, and 1 times 9, which is 9. And then we could simplify that. 9 goes into 12 one time, and then we have 3 left over, so 1 3/9, and that actually reduces to 1 1/3. In the second example, we have 5/9 times 3/5. Again, we're going to multiply straight across. That gives us 15 over 45. I can reduce top and bottom by 5, and that ends up giving me 3/9, and I can reduce that one more time and get 1/3. In the last example, we have 3/8 times 4/9. If one thing you can do, which we didn't do in the last problem, is that you can reduce out your fractions. So if I rewrite this as 3 times 4 over 8 times 9, what I can do is I can reduce before I multiply, just to make my reducing a little bit easier. So I know that I can divide this numerator by 3 and get 1, divide that denominator by 3 and get 3. I can do the same thing with the 4. If I divide my numerator by 4, I get 1. If I divide my denominator by 4, I get 2. So the answer I end up with is 1/6. Now I don't have to do that. If I wanted to, I could have multiplied straight across and got 12 over 72. And then I could have reduced. I could reduce top and bottom by 3, which gave me 4 24ths. No. Yes, 4 24ths, but I write down 26. It'll give me 4 24ths. And then if I reduce the top and bottom by 4, I get that 1/6. So I can do either method. What we want to move into next, though, is multiplying mixed numbers. And we are going to actually take a look at just 2 different methods to do that. The first method is just to rewrite our improper fraction, or our mixed numbers as improper fractions. So I'm going to take the number 2.5, and I know that if I'm talking about halves and I have 2 of them, that gives me 4 halves, and one more is 5 halves. So I rewrote 2.5 as 5 halves. 3 1/4, if I have 3 wholes but they're divided into 4 pieces, that'll give me 3 times 4 is 12, and then I have one more 1/4, gives me 13/4. When I have them rewritten as improper fractions, I'm going to just multiply straight across, and we end up with 65 over 8. And then our last step is to divide to get our mixed number back. So if I take 65 divided by 8, I know that 8 times 8 is 64. That'll leave me with 1 left over. So my final answer here is going to be 8 1/8. If I look at the next problem, when I go ahead and rewrite this mixed number, I have 3 wholes, but they're divided into thirds. So 3 times 3 is 9, and 2 more thirds is 11/3. 2 3/4, I have 2 wholes that are divided into 4 parts, so 2 times 4 is 8, and excuse me, 3 more is 11. So what I'm really multiplying is 11/3 times 11/4. If I multiply straight across, I get 121 over 12. Then I need to divide I know that 12 times 10 is 120, and I have 1 left over. So I'm looking at an answer of 10 and 1/12. So that's one method to multiply mixed numbers. If you don't like that method, you can go ahead and use the area drawing. Very similar to what we've done in the past with multiplication, what I'm going to do is I'm going to break my rectangle up into some parts. I'm going to separate my mixed number into a whole number and a fractional part, and draw a line. I'm going to do the same thing with 3 1/4. I have 3, and then I'm going to have 1/4 here, and draw a line. And then what I want to do is I'm just going to go ahead and multiply those individual pieces. So when I multiply 3 times 2, I get 6. When I multiply 3 times 1/2, I get 3 halves. Then I'm going to go ahead and multiply 2 times 1/4. That gives me 2/4. And the last thing I'm going to multiply together would be the 1/4 times the 1/2, which is going to give me 1/8. Once I have that multiplied out, then I want to add up my numbers. So I have 6 plus 2/4 plus 3 halves plus 1/8. I know that 2/4 is the same as 1/2, so what I have here is really 6 plus 1/2 plus 3 halves is 1 1/2 plus 1/8. So I'm going to add up the things that I can add up. I can add the 6 and the 1, which is going to give me 7. And then I have 1/2 and 1/2. That's going to give me 1. And then I have the 1/8. So then my final total, 7 plus 1 is 8 and 1/8. And that matches up to the method we tried above. All right, let's try another one involving the area model. I'm going to erase a little bit so I have room. So we're going to take a look at 3 2/3, and we're going to divide up our rectangle. So the whole number part is 3, the fractional part is the 2/3. Then I have 2 3/4. And then I just multiply. So I'm going to go ahead and take the 3 times 2 is going to give me 6. Then I can take the 3/4 times 3. That's going to give me 9/4. I'm going to take the 2/3 times the 2, which is like 2 over 1. That's going to give me 4/3. And then finally, I'm going to take 3/4 times 2/3, and I remember that I'm multiplying just straight across, so numerator times numerator is going to give me 6. Denominator times denominator is going to give me 12. So now I need to add up my fractions in whole numbers. So I have 6, I have 4/3, I have 9/4, and I have 6/12. Well, I know that 4/3 is really 1 1/3. I know that 9/4 is really 2 1/4. And then I know that 6/12 is really 1/2. So if I add up the whole number pieces that I have 6, 1, and 2, so that's going to give me 9. And then I need to add up my fractional pieces. I have 1/2, I have 1/3, and I have 1/4. I need to find a common denominator. My common denominator is going to be 12. So when I convert 1/3 into 12ths, I'm going to need to multiply top and bottom by 4, so that's going to give me 4/12. Converting 1/4 into 12ths, I'm going to multiply top and bottom by 3, so I have 3/12. and 1/2 into 12ths. Ooh, I already had it in 12ths. That's 6/12. So now I can add up what I have. So I still have that 9, and then I have 4 plus 3 is 7, and 1 more is, or 6 more is 13. So I have 9 and 13/12. I know that 13/12 is the same as 1 and 1/12. So really I have 9 plus 1 and 1/12. And that's going to give me a total of 10 and 1/12 as my answer, which is the same as what we got above. Okay, we're going to take a look at division, and we can actually look at division or attack division in 4 different ways. The first method is to use a measurement picture. So we have the division problem 4 divided by 1/2, which means we're looking at how many halves does it take to make 4. So in my picture I have 4 squares, and I want to figure out with these 4 squares how many halves that is. So what I can do is I can divide up my squares into halves, and then I can just count how many of those I have. So I have 1, 2, 3, 4, 5, 6, 7, 8. I have 8 halves that will give me 4. So 4 divided by 1/2 is equal to 8. I have 8 halves. I can also attack the problem using common denominators. So looking at 4 divided by 1/2 again, I'm going to set it up and take a look at the denominators. So I have a 2 in this denominator. 4, I'm trying to give it a common denominator. So right now 4 has a denominator of 1, but I want to make a common denominator. So I need to multiply the top and bottom by 2 to make my denominators the same. So now I have 8 halves divided by 1/2. And so basically I'm going to look back to what we did up above there, and that was how many halves does it take? So I need 8 halves. So my answer here is going to be 8. Another way we can attack problems is by looking at a diagram. So a part to whole diagram, and I'm going to look at the circular form of that. So in the problem we have here, 1/2 divided by 1/8, I'm going to go ahead and look at a circle, and I'm concerned about this 1/2 part. The problem's saying how many eighths are in a half. So I have my half highlighted. I'm going to think about what an eighth looks like, and I can see in my picture here that an eighth is just a little piece here, but I wanted to fill in the half portion. So because I have my triangle divided up into eighths, I can see that it is going to take it's going to take 1, 2, 3, 4 of those eighths to make up a half. So 1/2 divided by an eighth is going to equal 4. So in problem B, I'm looking at 1 2/3, and you can see here I have 1 whole and I have 2/3 marked off, and I'm dividing that by 1/6. So I have another drawing here just so we could see what 1/6 looks like. So I want to figure out how many 1/6 are in 2 1/3, and I can see that if I divide up my circle into 6, 1, 2, 3, 4, 5, 6, there's 6 there, and if I divide my 2/3 up into 6s, I have 7, 8, 9, 10. So 1 2/3 divided by 6 is going to give me 10. It's saying that there's 10 1/6 in 1 2/3. I could also look at the method that we were using up here with the common denominator. I can take 1 2/3 and rewrite that really as 5/3 divided by 1/6. I can use the common denominator method. I want a common denominator of 6, so I'm really looking at 10/6 divided by 1/6. And so if I have 10/6 and I'm looking for how many 1/6 are in there, I know that my answer is going to be 10. So you can either look at it through picture form, or you can look at it through the denominator form. And then finally is the algorithm. Again, what I would suggest, and what I think the Common Core encourages, is that you give students a variety of different methods to divide fractions before you teach them an algorithm, so that if they ever forget the algorithm, they can go back and think about it logically. So the algorithm for division, if I divide two fractions, the algorithm says that you're going to actually rewrite it as a multiplication and take the reciprocal of the second fraction. So we rewrite it as a multiplication, and then we take the flip of the second fraction. So what that would look like from 3a, we had, let me change my color, we had 1/2 divided by 1/8. What that would look like is 1/2 times 8/1. That gives me 8/2, which is 4. If I try it for the fraction I have in part B, I'm going to take 1 2/3. I'm going to rewrite that as 5/3. So 5/3 divided by 1/6. That's the same as 5/3. That's the same as 5/3 times 6/1, which is 30/3, and that reduces to 10 as well. So we have 4 different methods we can use. Okay, on this last page, you should have this in your notes already. I have 5 different application problems that involve either adding, subtracting, multiplying, or dividing mixed numbers or fractions. So I would like for you to complete those 5 problems before you come to class on Tuesday, and we will go over the answers on that. There is one more Explain Everything you will need to watch, covering 7.1.